This time on the Random Junk Channel, we're going to be working on this Christmas house. It is a no-name brand, but I wanted you to see how it looked in the dark before we start, because it looks like it's fully functional as far as lighting goes, but it still has some issues. So that's what it looks like right now. Go ahead and turn on the lights. And there are blue lights in the front and green lights on the base of the house, and all these red lights and these blue lights here that are not functioning. So there's about half the lighting's working and it's quiet. Should be sound. So we're going to see what we can do to try and get this working again. Normally when the sound fails, it's not repairable, but we'll see what we can do, because that's what we're here for. So again, this is a no-name brand. It's a PAC BVI made in China from 2007. There's the speaker. This is the 3 AA battery pack. The AC adapter goes in here and it plugs in right there. So it's 4.5 volts, and you have an on-off demo. So on, we got lights. Demo, we get nothing. Now that's on battery power, and the reason I have the batteries in here is I'm going to take the batteries out. And I will plug in the AC adapter. Click. Nothing. No lights. No sound. If I go to the demo mode, nothing. So, and yes, there is power on this. This AC adapter is, I checked before I started the video. The AC adapter is putting out 5.15 volts because there's no load on it, so it's got free float. So the only thing I can get to work is the lights, and not all of them, about half of them with the AC adapter, and that's with batteries, without the AC adapter. Sorry. Let's see. We'll start on the bottom. We have 5 screws, and then on the back we have 4. The front and the back come off independently from each other. So let's start with the bottom, because that's usually where everything is attached to. There's a lot of wires in here. Alright. There we go. I mean, there's quite a bit. And the circuit board's attached to the back. But, while I have it open, I can quickly examine the AC adapter. Yeah, I mean, it looks okay. Speaker, solder joints failing, but I should have had noise. I'll go ahead and probably touch that up and see if the speaker works. It is a 8 ohm half watt speaker, just larger than the Limax ones, as an example. Same power. Now there is something rattling in here. Or there was. I think it got wedged. Oh, there it is. Piece of glue. Now I'm going to take the back off. So I got the bottom set back on. Just onto its plate. go. And there we go. And that's all the screws. I'm examining the board. I'm looking for any burns on the top. It actually uses quite a bunch of screws to hold it down. Most boards have like 2. This one's got 4. Some of the broken glue pieces and dispose of them. Nothing obvious on the circuit board. I'm going to examine the blob chip, which is right here. A little bit closer to me. Well, there's a hole in the blob. So I have 2 magnifiers on to see it. It's not a huge hole. I don't know if the camera would show it. There's no burns on the back. You can barely feel it with my fingernail. But nonetheless, there is an actual hole and crack in the epoxy. Could be a defect or it could have popped. That sucks. But we're not going to stop. We're going to check everything out and see if we can get this thing working 100%. I am assuming the lights that don't work flash. And the reason I'm saying I'm assuming they flash is based on all these little components on the back of the board. We have on the back of the board, we have a lot of resistors. We have some capacitors and we have transistors. And transistors are used predominantly on these for flashing lights, whether it's Department 56, Limax, no name Chinese. Transistors are good for making flashing lighting circuits. I'm going to remove the jagged glue. So I'll poke myself with it real fast. It's not going to do anything to the board. It's just a piece of glue. Get rid of that. So if the transistors aren't receiving the information on when to turn on and turn off the lights, that might explain why we're not getting the roof lights or the border lights or the bottom of the house lights. Wires, they all look good. There is a buttload of them, as you can tell. They're all plugged in. Very nice. Better than some of the modern houses and the more expensive houses. I know the backlighting works. The backlighting lights are in here. They're held in with a little glue and tape. Not too bad. What else is inside? Just a whole bunch of lights and wires. So they don't have any floating circuit boards anywhere, like what Limax does, where they have a distribution board or a light distribution board. Every single one of these has its own wire that runs into this rat's nest right here. So, not too bad. Well, since we know some of these lights don't work, and I can see all the green ones right here are all tied together, I'm going to try and trace this back. So the green wire, so what I'm going to do is try and do it this way, make it easier for you all to see. There's a button there I didn't notice. You know what? Let's put the batteries back in it. Let's see what happens when I press the button. Put the cover on so the batteries don't fall out, although they fit really snugly. Still gonna put it in there. Let's turn this on. See the backlights come on. Orange, orange, orange. Okay, I'm going to flip it over so you can see what's happening. Just need to make sure the circuit board doesn't touch anything. There we go. So the button that I didn't notice because I'm not too observant apparently today makes all the lights flash. It's supposed to flash to the music. Interesting. That's demo mode. So we're going to change the direction of working on this. Let's just work on here. So what I want to do is I'm going to find another speaker that I can. Oh wow! See if I just have a blown speaker. That'd be cool. If its speaker does work though, I'm gonna have to stop it immediately because the music this plays is copyrighted, and I am dealing with that like every video now that I post. So, give me a minute. I'm finding a speaker. Slightly different, but it'll work for testing. It wouldn't be one I would put in here permanently. Now I just need some wire. So the speaker is a male. You know, screw that. I'm just going to desolder it from this speaker. I'm not going to screw around with it too much. So this is a brand new speaker. It's a little louder than this one. You can tell it's also much deeper. It's not a flat speaker. It won't, dimension wise it would fit in here, height wise it wouldn't. So sorry, diameter wise it would fit in here. So there's still a good chance that this won't work, only because there is a crack in the blob chip. I will try and set the circuit board at an angle so maybe the camera can pick it up and I can try and zoom in so you can see what I'm looking at. I can't guarantee that the camera will pick it up. Also, I'll try and hold the wires out of the way because that's one of the nice things about the otoscope is with that little point on the end of it, I can spread it between the wires. That right there. Or I can slide it between the wires. Okay. This speaker even has the, tells you what color wire goes where. How fancy. Plug it in, plug it in. You know, Glade plugins. Lights are on. Lights are flashing. Still no sound. So you probably can't see very well. You can. You can see kind of the flashings in the corners and down along the edge as it's going through its music. We'll turn the power off. There we go. Kind of what I was afraid of is I had a sneaky suspicion when I was messaging the person who owns this piece back and forth that there's a good chance that the blob chip, which is your sound, had probably failed. They don't last forever. Age gets to them, and well, they die, and it happens with all the companies. They always record the sound on the blob chip, and then they sometimes use an amplifier chip to make it louder. This one doesn't have an amplifier chip. Most Leamax doesn't. The one that uses the amplifier chip the most is Department 56. So, there we go. Much better solder joints than what was there when I opened it up. We'll plug in the factory speaker again, and we'll try it one more time. So I'm going to have to assume that the crack on the chip is probably on the leg that goes to the sound. I'm going to trace back the tracks. Yeah, there's nothing going to the speaker. Alright, so let's turn it off. Now we'll trace the speaker up. The speaker goes to right here. And now we'll trace it. This goes to pin 4, and use a magnifier here. So this outer one goes to pin 4, and this inner one goes to pin 2. So we'll flip this over. Pin 4. Pin 2. There's no discoloration. There's no resistors or components between the speaker connection and the chip. So it's the speaker is directly driven from the chip. So it doesn't go through the smoothing capacitors, and it doesn't go through any of these discrete components here, which is your transistors, diodes, resistors, and capacitors. The only thing on the top is a couple of capacitors. We have a jumper, we have a Zener diode on either side of this, either a transistor or triac. It is a transistor. There we go. Had to wait for the glare. Sorry, that's not a Zener diode, that is a resistor. The glue looks pinkish with the reflection of the wires that are red above it. Take a closer look with the magnifiers on max magnification at these components. Make sure there's nothing that I can see, but all the lights are working. Like I said, the lights are probably what these all go to. That looks good, 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 good. This one's a different color. Doesn't mean anything. Could just be the way the protective coating was put on the board. It might be thicker on this one. We'll check the track, see where it goes. That goes. That goes to the center where the crack is. Very strange. Let's see where the other end goes. Goes up to the resistor, and then it goes up to this pin here, which is this set of wires here. Which is this set of wires here. 1, 2, which go to the lights right there, which worked when the house was on. So I think it's just the coating on it is what caused the one to be a different color. The rest of them all are the same color. I think it's just the coating's a little thicker because they have a curl of coating right here too. They coat the boards to help prevent them from being conductive in case they touch something. It's like a varnish or a lacquer. All right, excuse me, I'm going to try and zoom in the camera so you can get a better look at what I was seeing with the magnification. So I'm going to zoom it in, and then I'll adjust the board appropriately. Since, there we go. And we'll turn this. There's the board, and trying to make it so the wires are the most open. That's going to have to go the other way. And let's split some of these wires up. A lot of wires. There's the chip. And let's try and get it more centered. See if we can get a couple more of these wires out of the way. Like that. There we go. It's nice and shiny, except for where the hole is. There we go. And see if I can get a little closer, and I'll see if I can add, whoops, wrong way, and add some light. You can just barely see it now. So that right there, that little dot, 2 dots side by side, is an actual crack. So let's see if I can just do a little bit of illumination. There we go. So you can really see the 2 holes. Well, if you see the little white lines that go across the top of the 2 holes, kind of looks like a Roman numeral, or yeah, Roman numeral 2. Those are cracks. If you look at the rest of this, it's all shiny and smooth. There's a nick right there in the middle, but all these lines at the bottom are actual cracks. And those 2 dots are actual holes they go through. So the bottom of the blob chip has split or cracked or gotten hot or just deteriorated from age, since this, I think it said 2007, which would be, you know, almost 20 years now. I know it's on here somewhere. Yeah, 2007. So you can, well, let me zoom out. I just realized you're just staring at plastic with a wire. There we go. You can add sound to it, but the sound won't match the flashing lights. So the sound is set to dance or move or flash, however you want to refer to it as, to the music. And according to the owner of this piece, it played TSO, which is why I said I would have to instantly, if it played, turn it back off, because TSO is copyrighted music. Most music now is copyrighted. I'm getting hit for Christmas music from some of these houses now, because apparently there's copyrighted Christmas music, and Yeah, it's a lot of fun. So, but I don't know why this isn't working yet though. So we'll look at that next. But as far as the sound goes, I'm getting nothing out of the board. These connections here on the board look good. I'll do one last test. I will test the signal coming out of the board real quick, just in case one of the wires is broken internally. It does happen. It's rare. It does and can happen. So there. Turn this back on. Click. Press the button. Click. Okay. Nothing and nothing. Press the button again just to see if something changed. Whoops, keep slipping. Nothing. I wasn't getting anything. I keep slipping off the solder joint. I keep slipping off the solder joint, touching the track next to it, which has power. I'm trying to stay on the solder joint, and nothing. So, unfortunately, this is one of those pieces that I won't be able to fix because it's a bad. We're not getting signal, which indicates a bad blob chip. The signal is determined on the blob chip, and if the blob chip fails, whether it just burns out, cracks, bubbles, smokes, there is nothing between the blob chip and the speaker except for the wire. Tracing these two tracks back, you can see it's I don't know, you probably can't see, it's small, so I'll zoom back down, turn it off again. Readjust. So speaker wire, which is right here, it's these two, something smaller than my fat finger. It's these two pins here and here. And if you follow, this pin goes to the second position. This pin goes to the fourth position. You can see there is no components in the path of the speaker. So none of these components all over this board interfere with the speaker. There's no resistors, capacitors. Capacitor would be what I would expect to see. Diodes, nothing. It is straight from that chip. So the only way for it to non-function is a bad speaker, or bad wire, or bad chip. But there's nothing coming out of the board. So I'm leaning towards that. Chip is bad again. Oh, there's also a hole in it. So a crack in the blob chip doesn't always mean it doesn't work, but what it does mean, it can get moisture inside of it. So there's an ingress point for the moisture, and when that happens, the moisture can corrode the inside of the chip, which is bad, and then it starts to fail one leg at a time. I don't know what it is or why it is, but it always causes the volume to fail first. Always. It is almost 100% guaranteed if you have no sound and it's not a bad solder joint or just a bad speaker in general, your blob chip has failed. Like I said, the only one that has something excuse me, in between is Department 56 that I have seen, and they run a an amplifier to make it louder, which takes some of the stress off the blob chip, because when this turns on, whatever volume the blob chip is set at is what feeds the speaker. Or if you have a wheel or a volume knob and it doesn't have an amplifier chip, it's the same thing. You're taking out the max power of the blob chip to the speaker, then you're controlling the resistance going to the speaker, which gives you your volume control. By putting in a amplifier chip, you're relieving the stress from the blob chip, which usually means it lasts longer. But also means it's more expensive, because that's more circuitry, more components, so on and so forth. A lot of things work that way. For instance, I used to build a lot of cars for TV where they had the sirens, police cars, fire trucks, ambulances, etc. And those control boxes that give you the sirens have a sound chip. That sound chip goes through an amplifier to make it go to the speaker. The sound chip couldn't power the speaker that blares the siren at you, so the blob chip that's inside, which is a sound generator, goes to a transformer, which then is your amplifier, and now it's really loud. Which is also why sirens are more on the high end, because it's a high-end amplifier, meaning it does the higher sounds. It doesn't do bass or mid-range, which is why sirens are ear-piercing. So, similar to what Department 56 does, and everybody else just runs it right off the blob chip. Now, see if we can find out why the AC adapter doesn't work properly. So the battery pack's right here. The battery pack negative is tied in with the negative for the AC adapter, which is this orange and black wire, which is soldered right here, which is connected adjacent to the speaker. And then that goes through the transistor and the capacitor. So all these components right here, this little section, give it a little light right there, which I was naming off earlier as a resistor, a Zener diode, a transistor, I think I might have found the reason why this all started. So, right here on the board is a slightly different color, but I didn't see anything. I see it now. It's got a burnt component. That could have fried the chip. Wrong power supply. I'm going to zoom back in so you can see what I'm looking at. Sorry about the zoom ins. It's never where I have the item. It always zooms in somewhere else. So, if you look at the full board as it sits, it probably looks just completely normal. But if we go where this orange and black wire are soldered in, which is these two right here. I don't know if you can see how this is all green, about the same color, and this one's slightly darker. And it's kind of hard, the lights really glare, at least in the viewfinder it looks about the same. But there's a tinge of tan right in here, because this has gotten warm. So now we're going to try and flip it over. I don't want to break the wires. And I'm going to bring another light. I don't want to swamp out the camera, so I don't want to have it super in the way. Let me get these wires off to the side. So I was saying we have a resistor here, which is fine. A Zener diode, capacitor. I didn't see this resistor here. I don't know if you can tell. It's kind of hard to see with the light. You notice how dark it is? It's because it's burnt. That resistor got hot. And I wonder if it took out this. This is a high-powered transistor. That's why it has a hole in it, so you can screw it to something like a heat sink. And this resistor is blackened. This resistor comes off of these two wires, which is our AC power. So this comes in, it goes through smoothing capacitors, a diode, a resistor, transistor, and another resistor. I'm wondering if somebody plugged in the wrong power supply. Alright, so now I'm going to turn off the light and zoom back out. Always go the wrong way. There we go. So this is less of a repair and more of a diagnosis. I can replace the burnt resistor. It doesn't mean it's going to do anything as far as the speaker, but it might make the AC power work. So we'll grab a piece of paper and a pen, so I can write down the color code, because even though it's burnt, I can still make out the color code, which is rare. I'm not going to complain, because it's kind of nice. Getting too much shadow. I can make out 3 of the 4 bands at least. It lowers the amount of guessing that has to be done. Brown, something, black, gold. That's something. I think it's brown, brown. Brown, brown, black, gold. Let's just double check. Brown, brown, black, gold. There we go. Check my resistors and see if I have a brown, brown, black, gold. Which I should, because it's 100 ohms, which is a pretty basic. Half-watt resistor. I don't think I have any half-watts, but I have some 1 watts. So we'll probably just swap it out with a slightly bigger one to try it. So we need 100 ohms. 100 ohms should be in this section. Not, which means it's been moved. 170. Oh, there it is. It's put on the wrong side. That's all right. So, let's see if we can make the AC adapter part work. There's no guarantee because the diode could have been damaged and the transistor could have been damaged. The diode might be damaged. I recommend if you have to do... Oh yeah, the diode split open. Never mind. It got the wrong power. Yeah, the diode's completely split and bulged. And the transistor has a bubble in it. So everything got damaged, except for the capacitors. They're not blown up. When capacitors get damaged, they swell. These aren't swollen. So replacing this is probably useless because I don't have that transistor. Let me see if there's a part number on it. There is. Can't read it. There is. Because part of it's melted. Jeez. Alright. I don't know if the camera will be able to see this or not, so I'll try. I want you all to see what I'm looking at. If you're ever at Walmart or Walgreens or any of the other wall pharmacies, joke there, and you do small stuff like this where you need the solder or what have you, buy one of these. This thing was like $9. It's like the greatest thing ever. And you know, if you want to check your ears, nose, and throat, there you go. It comes with multiple tips, but it's a magnifier and it pinpoints and it lights up. It's beautiful. You can use it as a flashlight if you want. I don't see why. It's not very bright, but yeah, I use it a lot. If you watch videos ever since I bought it, I've been using a lot. And the reason is I was going to get one of the digital magnifiers that I can project onto a screen, but when I was testing the idea, the camera was just picking up the black lines because of the shutter rate of the camera and the projection rate of the screen. And this camera that I'm filming on isn't new enough that I can plug it in and have it actual, you know, do like a split screen. This camera's kind of old. So, but it works. Hence the reason I still use it. Don't fix what's not broken. Alright, I'm going to zoom in, and if I can't get it to show, I'll see if the macro setting on my phone can get pictures, and I can just post pictures at the end of the video. But let's try. Here we go. Going down. Whee. I'm going to go into maximum zoom in. And there we go. Yeah, it's not too bad actually. I'm surprised. I'm going to use this again for a light. So, and I need a pointer. Use something smaller since we're now at maximum zoom. So it's got that thermal stuff on it, but pointer in frame. Get off the wire. There we go. Apparently there's stuff on the pointer. Look at that. This is a pick, and look how nasty that tip is. You can't even see that with your human eye. Anyway, besides the point. So it's got the thermal coating on it, or the glue. And I'm trying to get it right there. That is a hole. Not that big hole, but that right there. Yeah, right there. But right here is the part number. You can kind of make out some of the letters. That is a huge bubble of melted transistor. That blob right there. Now look at the diode. So you can see the resistor is burnt. I don't really think I need to shine too much light on it, but this is really hard to do using the magnifier to show everything, since it's really small and there's a delay between what I'm doing and what the camera sees. So get back in here. You can see the burnt resistor. See how the diode is swollen? It goes cylindrical and it flares out. It's not supposed to flare out. The side facing the transistor is split wide open, and this black stuff right on the top there has oozed out, which is burnt material. I'm going to see if I can flip it. Big dissection for such a small little thing, but I try to show everyone what I see if I can. So I'm not going to be able to use the pointer because I have to hold the circuit board. But look at the size of that crack. Now on the camera it looks huge. This thing is itty bitty. I'm surprised. I've never, since we had the programming on this camera, I never tried maximum zoom, which actually works pretty good. But you see that big old split? Starts there and gets really fat right there. I use the pointer now with no additional light. Pointer in frame. So the crack goes, opens up, and then you can see the blackness right here. And then there's some on the metal that's soldered in. Yeah, based on where it is, and those two capacitors are perfect. There's no swelling, there's no discoloration, there's no leakage. I'm going to zoom out now. So actually that's a really good shot right there. All three. Hole right there, that little dot. Hole right there, that weird shaped dot. Burnt and blown up. The only thing that's still good are those capacitors based on appearance, and that resistor right there hiding behind the transistor. Those are the only things that appear to be in decent shape. So what I'm thinking happened is a power supply was plugged in that was the wrong power, or the power supply was defective and put out too much free float. Now, 47 minutes, and all I'm doing is going through what I do off camera sometimes, just so you can see how long it takes to do some of these. And unfortunately this one isn't going to be repairable. I could probably find the transistor and the resistor and the diode. I'm sure I know I have the resistor, bigger, but I have it. The diode, I should have some Zehners. I would have to try and figure out which one it is, since the number is on the side that's split open and blown apart. And the transistor, I can make out a few of the digits. I can do transistor. All that's going to do is allow it to be plugged into a wall. That does not affect the blob chip, that's just the power. That's why the black wire is shared between the battery pack and here. The difference is the positive wire from the battery pack goes right into the board, while the positive wire from the power supply gets through all of this, because batteries are straight line DC. What about that fancy piece of paper? And the meter shows you too. So DC, if you notice, it's a straight line and then there's a dotted line for DC, and then AC's got a squiggly because AC's a squiggle. So DC, the reason a lot of power supplies, when it has a power port, have a smoothing capacitor is because your battery just puts out a constant voltage until it starts to die. Then of course the voltage goes down. We just tip it like that. Now it's dying. Whereas a power supply can put out square wave, where it does this. It's still DC because it's not dropping below the 0 point, so it's pulsating. Also, some DC is staticky, so it's not a straight line. Well, it is a straight line, but it's a squiggle that generally doesn't drop below the 0 line. So that means that all your power is up here, and on this one the power starts reading usually about halfway when the lights start working. But this does it so fast the machine doesn't notice it. And then the squiggly one, the 0 would actually be down here, and this would be 4.5 volts, would be noisy. It's noisy DC, and that's what these capacitors are for. It's to get rid of that noise. And then the diode and the transistor help with the wave, try and make it more straight, like a battery. But a battery, the longer you use it, the weaker it gets. AC power, power supply, AC adapter, doesn't. It just maintains. Now if your power supply is bad, you can have problems. the end of last year was the most pieces I've ever received that had power supplies that have failed. So either they were sent to me and they were defective, meaning there was like 0 volts coming out, means it's dead. And I've had some that were sent to me that were 3 volts putting out 18 volts. 3, 18, big difference. It's a 3-volt power supply putting out 18 volts, and they wonder why their house got burnt. And it's because the power supply died. Power supplies can die in both directions. Too much power, not enough power. So you got to be careful. If you notice your power supply is starting to get warm, it's probably overpowering, meaning it's putting out too much juice. Or it's pulling too much juice and it can't handle it anymore. If you have you don't have to have a fancy multimeter. It doesn't have to be something high-end with graphical and all the other options. Just something that has the voltages on it are fine. The cheap, $5 ones from Harbor Freight or $10 ones from Harbor Freight. Check your power supplies. So this one that I had on the screen when I started, of course I threw the end over. This one is a Lemax, and it puts out 5.15. 4.5, 5.15, completely fine. I have one I had to throw away. It was Lemax that was putting out like 10.8. That is more than double without a load. That's crazy. That will blow a computer chip or a blob chip. It will blow the transistors. Because a lot of these might say 35 volts or 16 volts. Some of them say 10 volts. 10-volt capacitor, and you're putting 11 volts into it. The capacitor will hold up for a little bit before it lets all the stuff out of it. If you've watched all the videos, good for you. But if you have watched all the videos, you would see there's a few videos where I show capacitors that have blown up and the casings have come off, and that's usually because the capacitor either died, dried out, shorted out, or it was overpowered and they explode. They're like the miniature grenades. They go pop. Kind of cool unless you're near them, and they'll scare the crap out of you. And of course, the bigger the capacitor, the bigger the noise. So I'm going to go ahead and reassemble this. I'm pretty sure you can figure out reassembly. Some screws to hold the board on here, the 4 screws to hold the back on, the screws to hold the bottom on. Of course, all the screws are there and there. But unfortunately, after nearly an hour, I think I figured out the cause. It's an overvoltage, whether wrong power supply or defective power supply, and fixing the AC adapter isn't going to do much. All it's going to do is make the lights work. I will ask her, and if she wants it repaired, I will go ahead and order the transistor and a package of Zener diodes just to be safe, in case it's one of the ones I don't have. And I can make the power supply work, but the sound, unfortunately, will probably never work on this because the blob chip is split at the very bottom, and I'm going to believe it's probably from an overvoltage. Blob chips are very power sensitive. Too little, too much will crack them, split them, blow them off the board. I've opened, I'm sure some of y'all are familiar with the swinging ghoulies if you're a Department 56 collector. I have several of them here because they're a pain to take apart. And they're mine. I buy broken pieces. And inside there is a blob chip that makes the lights flash. If you put in the wrong power, that blob chip will physically separate from the board. That is the one I see the most common, where the blob chip is not attached anymore. It's literally stuck in the gearbox. It just falls off. It gets so hot it delaminates. It desolders itself. So they're very sensitive to power, and power creates heat. Heat creates separation, or cracking, or bubbling. And that's what the hole is. It's a bubble that forms. It pops and leaves a hole. Like popping is it. Leaves a hole. Same thing. So we don't want to run the wrong power supply so we can avoid it. Unfortunately, everybody makes mistakes. It happens. There's nothing you can do. And if it's out of your control, well, it's just bad luck. So I'm going to go ahead and message her, give her the news, and see what she wants to do. And then either if she wants this fixed, I'll go ahead and get the parts ordered, and I'll set this assembled so I don't lose any screws aside, and I'll bring the next piece in, because right now you can't tell, but I have 2 pieces over here, 1 piece over there, way over there I have 2 more pieces, and they're just waiting for parts. They're partially done pieces. 3 of them have videos. They're just not done yet because I'm waiting for the parts to show up. And one of them doesn't because, well, it caught fire, and there's nothing I can really do except I'm trying to see if I can find a circuit board. If I find a circuit board, I'll probably do a video, but I opened it up, and yeah, it's all black on the inside. So, wrong power supply. But anyhow, so in the meantime, thanks for watching. Again, sorry for the long video. Basically just being how the disassembly goes. If you have something like this, this is very reminiscent of the Avon style stuff from back in the day, the 80s. I don't think it's Avon, especially since it's 2007. I just think it's a generic, no-name piece. The name is the letters, but what I mean is it's not a name brand that we're all familiar with. It is not a bad looking piece. The lights are nice. It had TSO on it, so I'm assuming they paid TSO for the music, or, well, they stole it, one of the two. But, and I like the way they laid it out. Just because it's cheap doesn't mean it's crap. I like the fact that each thing's plugged in independently. I do like that. So if you have a row of lights that are bad, you can literally unplug it, fix the row of lights by resoldering new ones, and then plug it right back in. I like the fact that the speaker can be unplugged, replaced, and then just solder it back on and plug back in, instead of doing it off the board where they have the glue to help prevent it from being wiggled and broke. So, and there's enough room in here to have a storage compartment for your AC adapter. You don't see that anymore. In the 80s you used to, but that's why I said it's very reminiscent of 1980s type stuff. And it's got a big speaker, very rare. Most of them are itty bitty ones, and it's a low profile, which means it's going to be tinier or a higher pitch sound, but it still has a larger speaker, which will give you a little bit better sound range, but you're still going to be more on the high end. So there's always positives, even on the cheap stuff. I find some of the cheap stuff has stuff like this where there might be 1,000 wires, but each set of wires is independently run, which makes it easier to disconnect, to service, to reconnect, to reassemble. So I do buy some of these cheap houses from Goodwill when I find them, because they have stuff in them you can't find anymore. So, this one doesn't. It's just wires and plugs, but you'd be surprised what you can find inside these guys. So, I'll let you know in the comments below, not comments, in the description below what the results are. If you have any questions, comments, or so on, just put them below. I try to respond to everybody. Sometimes I get inundated and I don't have, I miss them. It's nothing, I'm not ignoring you. I just literally sometimes miss comments. Also, for some reason, I get notifications as there's comments and they're not there, and they show up 3 weeks later. So I have no idea what YouTube's doing. I know they're changing stuff, so that might be part of the reason. But you can always contact me via the comments, or in our description we have, you can do it through Facebook and or Gmail. So, but in the meantime, I'm going to assemble this, put it in the corner. I'll actually put it back in the box it came with, and let her know the bad news and see where we're going to go, and I'll put the information below. So thanks for watching. Until the next video, have a good one. Quick addition, I should have let you see what this thing looks like flashing, so this way you have an idea of what it still looks good for a Christmas village. I mean, at Christmas time my lights flash and I don't have any music, but I just wanted you to see some of the flash patterns it does. That way you can get an idea. Because I had it upside down, you couldn't see it on camera, so you had no clue what was or wasn't doing its thing. There are different flash patterns, I've noticed that. And then when it's done, it resets to the factory, just the windows and the tree. And as you can see, it also adjusts the windows too, where it turns off the lights inside the windows. So. go. There's a couple more. I was just playing with it to see what the different flash patterns were before I put it back in the box and take the batteries back out of it. But yep. So I mean, it's still not too bad for your Christmas display to have a house that has different flashing light patterns. But I understand without the music, it's not as good as it used to be. But still kind of neat. Um, Even as a rehab, it wouldn't be too bad if you wanted to rehab the house. Again, there'd be no sound, but you can enjoy the light patterns at least. Adds a little difference to your village because a lot of houses you just have standard lights. They don't have controllable lights. I know some of the new stuff you can control with a remote, but the flash patterns are all the same. This has multiple before it restarts, so I don't know. Adds a little flair. That's the word I'm looking for. A little flair to your village. Doesn't matter if it's a name brand village or not. It's still kind of neat to have something that stands out. So I'll let it finish this pattern and then call it good, and I'll let you know what the end result is in the description below. There you go. All right. Have a good one.